Hello, everybody. Thanks for coming out to the beginning of the first Flux Framework community meeting in this context. I was kind of hoping to be able to say that we were all signed and in with the HPSF at this point. Where we're sitting, as far as I know, is we have agreement in principle on both sides, and we're waiting for actual ink to hit virtual paper. Yes, I reversed that. I don't know why. But we should be actual members of the HPSF pretty soon. We're really excited about this and some new collaborations we've been starting recently. Just to introduce myself, I'm Tom Scogland. I work at Lawrence Livermore National Lab. I am the Flux lead, especially for research and scheduling, along with the technical leads, Jim Garlick and Mark Grandona, who unfortunately couldn't join us today. And thanks to a whole lot of great contributors and people, quite a few of whom are in the room, I'll probably point out at some point, we have some really interesting software and developments. And I'll give you a little overview of what we're about, what we do, just in case there are some folks who aren't familiar with us here. Kind of start us off, right? The goal at the start of Flux, and this was back in, actually before I was involved, 2012, was to build something as a next generation workload manager to try and get around some of the limitations, things we were running into, having problems with systems of the time, which, you know, looking back on them now, Torque and Slurm of 2012 are not what they are today. So the map has changed a little bit. But we were trying to design from the beginning for flexibility in resources, flexibility in how you run things on the system, more complex workflows, and being able to evolve with the HPC environment as easily as possible. We've had 25 plus contributors, including engineers who were on the original Slurm team at Livermore back before SCED-MD. And additionally, people with expertise in container technology, scheduling, workflows, cloud computing, all of this good stuff, right? But what is the software about? There are a couple of major things that are fundamentally different. I'm not going to dig super far down in the weeds and talk about how the overlay network is designed and all that stuff for today. But the two kind of fundamental things are Flux was designed to be hierarchical. There's no, you get an allocation and now you have commands that behave differently. You get an allocation, you get another instance of Flux in which all your commands work just like they did, barring policies at your site, the way they did outside of the job, just on the resources you have allocated. And you are an administrator for that instance. This means that we actually run new schedulers. So you can do progressively parallel scheduling across allocations, all kinds of other fun things like this. And it means that you can compose things in a way that wasn't very feasible before. You know, if you have several batch scripts that you normally run one at a time, you want to run them all in the same allocation, that just works, right? It's a little bit brain bending to look at how things work the first time. I know it certainly was for me. But once you get into this model, I kind of find it hard to go back to reasoning about the sort of limited levels that you can have in some other systems. Now, the other one, this is one that I was more directly involved with the initiation of, is graph-based resources. And calling it a graph is not necessarily my favorite. It's what we always do with this. But the thing that's really important is that as far as our scheduler is concerned, we schedule over completely dynamic blobs of resources. Nodes are special because we have to know what you can run something on. Cores are kind of special because we have to know that those are things you can run on. But almost anything else you could add in configuration later on and hook in with scripts, plugins, other things like that to be able to do your own containment, whatever you like. It means that we don't have to know a piece of hardware exists. And you could take a built binary of Flux, land it somewhere, add that yourself as configuration and some plugin or epilogue prologue work, right? That's where we want Flux to be, is to be able to grow with whatever the thing we don't know about yet is. Makes things a little interesting sometimes. Now, how's it used? This has changed significantly over the years. We originally built it as a system to manage capacity clusters, actually. In fact, there was a time in the distant past now where we said, we will never run on a capability system, like El Capitan. That's where we run now. So things have changed slightly, but we actually went from not running as a system scheduler on anything in the top 500 to 5 systems overnight. Couple of them in the top 10. It's also used in converged computing. You can run Flux with Vanessa Sackett's excellent Flux operator under Kubernetes, or the other way around. Some work to run Kubernetes under Flux with some extra support for managing that. You can run it in the cloud. We got a random email from Google one day. Hey, we made a button that you can put this on Google Cloud and get a Flux cluster. I don't know how well maintained that is at the moment, but it's progressively moving out there, right? And we want to support, as much as we can, complex heterogeneous workflows. This is something that ended up getting baked in a few years ago, and we had people come in and say, we need to run 15,000 simultaneous jobs. They are all different things. They have specific placement requirements. How can we do that? And now we do that on a regular basis. It also goes down to modeling, hardware and systems, and of course, some of us are progressively doing research, trying to figure out how to go to the next scale, the next level of throughput, the next thing for Flux. To kind of run down the timeline a little bit, the project came into existence in 2012, went through some substantial design review, initial prototyping. The first time it actually ran, could put a piece of software on a system, was in 2014. It was launched by Slurm or MPI exec or something else, and then it could subsequently launch basic MPI jobs. First time it was used for meaningful science was that complex workflow I was talking about earlier, part of the Cancer Moonshot project, Pilot 2, in 2018, which was meant to be a Gordon Bell, did not make it that way, turned into an SC best paper the following year, and has fed into how we maintain our flexibility for these kind of complex workflows ongoing since. Became an R&D 100 winner in 2021, and then finally, just in the last few years, we are now the system workload manager on El Capitan and a few other systems of its type. These are kind of the major timeline events, but what have we been working on? This is kind of an eye chart. It's a lot of detail. I'm not going to try and read all of this, nor do I think any of you necessarily should, but we're working on making it so you can get elasticity in your scheduler, grow and shrink jobs, have custom resource policies or module policies, be able to adjust things rather than having fixed options, be able to more flexibly consume resource and job events. This is, since early on, we've been saying, if you have a workflow, you want to run it. If you want to write a workflow manager, do that. Please do not write a scheduler. Use one. It's hard. And then, we keep working on optimizations, admin features, other things like these as we go. Now, all of that said, where are we going next? Taking grow and shrink and making it something you can actually use all the way through core. I mentioned we were working on it before. We have it in the scheduler, at least largely so, but figuring out how to make that manageable, how to make it work with policy, how admins can manage it, how users can use it, and have it not cause problems or priority inversions, or other fun things like this. That's what we're working on now. There's been some interesting work on MCP servers for hooking into Flux. This again is Vanessa's work. And being able to do, like, define and use different topologies through the system. Getting reservations, this is a big one for admins and centers. We know a lot of people want this for dedicated access time, other things like this. That is in active work. And of course, we're always working on higher throughput. You know, we think we get to where we want to be, you know, a few hundred jobs a second. Then we have somebody who says, well, I submitted 12,000 jobs all at once, and it took a while to start. Like, oh, okay. We'll work on that. In fact, I was writing a report on that this morning, and I think we'll have some progress pretty soon. Now, this is all kind of what we've been doing in production. We have some work going on. A little bit more on the research side. I'm not going to dig too far down. We'll at least highlight a little bit of what we've been doing as part of that project on the side. There's also a lot of really interesting agent-oriented work, modeling and description, other stuff I'm not going to try and talk about. If somebody wants to talk about it, please do feel free to snag me. But we've been working on making it so that you can have multiple Flux instances coordinate with each other. In the first model of this, we made it so that you can delegate a job. This is all up in a PR that's still in progress. This is not merged yet, but it's in the works. You can submit a job to a Flux instance, have it honor dependencies forward and backward, but have the execution and management of that delegated to another Flux instance. Why on earth would you want to do this? Well, if you think federated or other things like this, you want to be able to have a job that needs GPUs, but then needs to do some post-processing, pre-processing, whatever it is, bits and pieces that will run on a CPU node, run on a node with a different architecture. Maybe it's an AI accelerator, maybe it's a quantum resource. It doesn't really matter. It wants to run on something else. And ideally, you don't want to have to use the grad student scheduler and have it go and manually run things on each subsequent resource, right? This is unfortunately how this gets done a lot of the time today. Or in some cases, the postdoc scheduler, as the case may be, right? This is manual at the moment, but we're looking in the next couple of months, probably have this upstreamed actually available in production. The next step we really want to get to is making it so that you can submit work in a way that doesn't presuppose what kind of resource you're going to run on, can specify what you need so that your stuff can execute, or how to get to the correct version of it so it can execute where it ends up, and actually select target clusters for you so that we can optimize both for the user and get better utilization for the center, right? You have users that don't want to have to care, but they're willing to say, this is CPU only, this is GPU only, this is, you know, just downloading some stuff so it doesn't really matter if it's running on a cell phone core. Then we can put it somewhere where we're not wasting large chunks of nodes. And this is kind of our immediate next frontier for some of the stuff we're trying to do. There's a lot more going on as we're working toward 1.0 as well that I'd be happy to talk about. I'm not going to try and dig into too far here. At this point, I'd like to thank everybody on the Flux team who has been on the Flux team over the years. We've had a lot of great people actually in the room today. I mentioned earlier Vanessa Socket. We have Dan Milroy. We also have Chris Musa, Hobbs. We have Ryan Day, and some of our great collaborators as well, Hari, Jay, Ian. Thank you all for being here and supporting this event, and for everybody else. And of course, our community. If you're don't consider yourself part of it now, I hope you will choose to be, but I want to take what's left of our time to actually try and engage with you. What do you think you need? What is it that we're doing that we shouldn't be? What is it we aren't doing we should? I'll be happy to take some questions.
Hi, our GitLab runners running our CI jobs on resources like Frank are not set up to be more dynamic. They have statically defined limits, and it ends up in such a way that we don't use our GPU hardware as efficiently as we should. Could Flux help with GitLab runners?
It's possible. It's something that we discussed kind of early on, actually, trying to do. I don't know that it's been tried in exactly that way. It may depend on which way around you want to do it. I would suppose you'd have a GitLab runner that would receive some work, and then you'd want to allocate some resource to it, but I'm not sure how that's tied together. Looks like maybe Alec wants to chime in.
Yes.
Sorry, Samir. Hold on. Samir, I'm going to try and look at you while I answer your question, but be enough in the microphone that other people can hear me. A little bit to this extent. So at Livermore and a couple other of the sites that are running Flux, there is a Flux executor for the Jacamar plugin, and Jacamar communicates with GitLab and will run jobs on the behalf of GitLab and such. And so we do this at Livermore in the way of you have a Flux cluster, there's a Jacamar runner on one of the login nodes, and then that accepts jobs from GitLab and then spawns them off into their own little Flux allocations across the rest of the cluster. So you do get that dynamic allocation where you can ask for, just a couple of cores in a node so that you have exclusive access to like 4 cores out of 128 cores, all the way up to being able to do multi-node tests. So,
I would love
part
to
of it.
coordinate with you and see if we can better utilize the hardware.
Sure.
Yeah, that's something we can certainly look at, and it's at least technically possible. I don't know that we have anybody that does this in practice, but if you want to have users be able to run node exclusive but have your CI stuff run co-scheduled, that may also be a possibility.
That's my next thing that I want as part of this slide. Slurm does not do this particularly well, but it would be really nice to take that configuration and push it into, like, I have 2 overlapping partitions or 2 overlapping queues inside of Flux. If I submit to one of them, I'm allowed to be core scheduled. If I submit to the other one, I want to guarantee node exclusivity for either security purposes or some other reason. But in the CI/CD space, kind of like Samir is talking about, oftentimes my job only needs part of a node, and I don't want to reserve the whole thing, but the current way that we set up a lot of machines is node scheduled.
Right, and that's something that we're aware of. There are a couple of changes in flight we'll have to chain together to be able to support that well, I think, but it's something we're not real far from being able to do. So we should talk. Please.
So this may be like down to my not knowing the mental model of Flux, but I'm kind of curious, can you like allocate new resources? I know it goes against maybe what the intention of scheduler is, but can you allocate more resources on demand for a running job or sort of relinquish them? Or is, because I mean, the practical application here is like if you're doing, sampling, right? You're in an area of, hyperparameter space and there's more uncertainty, you need to expand it. And then you're like, oh no, actually I like this. And then you shrink down and you want like a constant time out of that.
Absolutely, so that is, I mentioned this kind of as an aside or items we're working on a couple of times. That's what I refer to as elasticity. We actually run partial release, meaning being able to give away parts of resources in production currently, but that is only accessible after the user job has completed. We're working on plumbing it through so that that's possible for the user to take advantage of without having to get to that end of job barrier first. That should come first, but that will likely be soon. We're talking to some collaborators about how to go from being able to request the grow from the scheduler, which Dan especially has put some great work in on. That is actually, you could go and test it today. But there's no user interface for it. We don't deploy it yet because how that hooks into policy, into accounting, how do you prioritize it? becomes a really interesting question very fast. But yes, that is absolutely something we want to be able to do.